Assalamu alaikum dear students. We are discussing the relation between the two sets, and in previous lecture we discussed the first concept, the subsets of A cross B. The subsets of A cross B, that is relation is the subset of simply A cross B, or we can define any subset of A cross B as a relation, the domain and the range of the relation, and if the cardinality of set A is n and set B is m, then the cardinality of A cross B is nm. So the total number of subsets of this A cross B is simply 2 raised to power nm. That is number of relation between the two sets. Set A, which has n elements, set B, which has b elements, is 2 raised to power nm relations. This we discussed yesterday. But here we will continue from this very concept, that is number of subsets. If A equals to cardinality of A equals to n, cardinality of B equals to m, then it has 2 raised to power nm relations, or there exists 2 raised to power nm relations from set A to set B. Let me consider here an example: A equals to 1, 2, B equals to 3, set 3. Here number of elements in A is 2, number of elements in set B equals to 1. So A cross B equals to clearly 1, 3 and 2, 3. It has only 2 elements because 2 into 1 is 2. 2 elements. So number of subsets of A cross B equals to 2 raised to power 2, because we know that for a finite set, number of subsets equals to 2 raised to power n, where n is the number of elements in a given set. That is 4. 2 raised to power 2 is 4. So there are 4 subsets of A cross B, and these are R1. Let us denote these subsets by Ri's. That is R1 equals to 1, 3, R2 equals to 2, 3, R3 equals this whole set, because every set is subset of itself. So let us denote this A cross B as R3, and R4 equals to null set or the empty set, because every set is null set is subset of every set. So these are the only 4 relations possible between A and B. These are the 4 relations from A to B. Now here this subset R1 and R2 subset, this R1 subset and R2 subset of A cross B, it is a proper subset, because this set is neither empty set. These sets are neither empty sets nor they are equal to the given set. So this means that these are the proper subsets. When they are proper subsets, when we consider proper subsets as a relation, then these relations are simply, or these subsets gives us the proper relation between A and B. So here we have 2 proper subsets, hence in this way we have 2 proper relations from this set A equals to 1, 2 and set B equals to 3, 4. R3 equals to A cross B. This is the improper set, because this set equals to the given set. Here this very relation, the relation represented by this improper subset, is called as the universal relation, while as the relation represented by this null set or the empty set, it is called as the empty relation or null relation or void relation. In sets we have 2 ways to represent or express a set. One is the set Builder form, or second one is the tabular form or roster form. But here we can represent the relations in 3 different ways. One is the set Builder form, tabular form, and third one is simply the visual representation. Like if we consider a set A and B, any 2 subsets, set A and B any 2 subsets, any 2 sets such that 1, 3, 1, 5 and 1, 7. Now clearly it is the subset of A cross B. it is subset of A. It is given that this is the subset of A cross B. So when it is a subset, it is a relation. This representation 1 3 1 5 1 7, this is the relation. This is in tabular form because we enlist each and every element of a given set. That is why this very form 1 3 1 7, this very form, this is the tabular form of this relation, or roster form of this relation. Similarly, we can have this set builder form. Set builder form is that form in which we enlist the property. That is, actually it is a set of ordered pairs, which implies that xy, set of all ordered pairs xy, such that y equals to 1 plus 2n, where n equals to 1 2 3 and x equals to 1. Here in this relation 1 3 1 5 and 1 7, first entry is 1. So here x is 1, which is here I write this x equals to 1. Now the y is 3. In first we have 3, 5 and 7. So this means that when we consider n equals to 1, where n equals to 1, it is 1 plus 2 into 1, that is 3, 1 plus 2 into 2, that is 5, 1 plus 2 into 3, that is 6. So this means that this is one way to express this very relation 1 3 1 5 1 7 in this set builder form. There are number of ways to express this in the set builder form. Now the third representation is the visual representation. In which, in this representation, we draw two circles or curves. In first curve or circle, we write those elements which are in the domain, or we write simply the domain set, and in second we write the range set. Here one is in domain because, and in range we have 3 5 and 7, that is 3 5 and 7 in the second. So here one is related with 3, one is related with 5, one is related with 7. So this is the visual representation of this said relation. Now here in this R3, here if we consider the previous this one R3 A cross B, this is the universal relation. How to define the universal relation? Universal relation is the relation which is represented by the improper subset, that is, which is represented when we consider A cross B as a subset of A cross B, then that very relation is called as the universal relation. So how to define this universal relation? In this universal relation, we consider each and every ordered pair from A to B. So this means that when we consider each and every ordered pair, this means that each and every element of first set, that is set A, is related with each and every element of set B. When this happens, then such relation is called as universal relation. That is, if every element of A is related with each and every element of B, then relation is called as the universal relation. And the third one is here null relation, because R4 here R4 represents the null relation. Null relation is that relation which does not contain any element. When we consider this null relation as the subset of A cross B, so null relation is simply that relation which does not relate any element of A, any element of the first set with the second, or any element of A with B. So this is null relation. How null relation exists, we will, when we discuss this exercise, corresponding exercise of this very topic, that is relation, I will show you how null relation exists. Like when I showed you also how null set exists. Similarly, we can show this, we can prove, or we can show how null relation exists between the two sets. So thank you. Inshallah, in tomorrow's video lecture we will discuss the corresponding exercise on this relation. So thank you.